Hello everyone, this is Shatarupa and welcome to Rasayanika. So hope you all are doing well. So yesterday was our third session on the CSIR NET rapid revision rounds. So today is our fourth session on the CSIR NET rapid revision round. So before starting our session, I would like to check that am I audible to everyone? Please type in the chat box so that I can check whether I'm audible or not. Yeah. Rajrupa, good evening. Yeah, Rajrupa, good evening to you all. Yes, ma'am. Okay, so I am audible, right? Anyone else there? Would you like to comment? Orgudeep. Yes, ma'am. Okay, Orgudeep, so I am audible, right? So before starting today's session, I would like to say one thing to you that yesterday I have told about some important topic which are very relevant to your CSIR NET examination, right? So today I am going to talk about another important tips that will definitely help you to prepare yourself far more better for your CSIR NET examination. You should remember one thing, that you must prepare your own note before your examination. If you really want to crack the Jrf or the CSIR NET or any national level examination like CSIR or GATE, so it is very important for you all to make your own note. Suppose you are reading any books for a particular topic and making clear your concepts, and also you have referred so many books, other books, also lectures, you have attended so many classes or lectures or any study materials, right? Anything else. But one thing you need to do, one thing, that is you need to prepare your own note. That is, just maintain a notebook of yourself for each topic or chapter. Just leave there for 2 or 3 maximum pages, not more pages. Actually, you need to prepare it in a concise manner, okay? Because in this 2 or 3 pages, just you need to write all the concepts you have gained, all the data you have collected, all the important formulas, the units, everything related to the particular that topic. And already you have read so many data collected from so many books or lectures, everything else. So just put down or write down all the things, important concepts, all the you have underlined so many points in many books. Just keep there, and within 1 or 2 page maximum, so that will how this can help you. Because just before 7 days of your examination, or just the last night preparation, when you are in very rush for your preparation for your examination, so then what you need to do, just go through those your own prepared note, just turn over the pages and just read all the important points, all the formulas, all the conversions you have mentioned there, all the important point you have underlined there, all the marked harder problems you have marked there, that you had collected an important point from that. Okay, so just go through that. It will help you to remember any important thing that you can, or the any other thing, like you can make mistakes in your examination. So it will definitely help you to prepare yourself far more better. So this is the another thing, you must keep preparing this type of note actually throughout the year, not just before 7 days. This will help you. This will help you actually before 7 days or just last night preparation or 1 month preparation. But you need to prepare by throughout the year while preparing. Okay. So this is another important point which I would like to share with you all. So this was that. So let's start today's session. Okay, anyone from you commenting in the comment box? Hamad. Hi, ma'am. Hi, Hamad. Good evening, ma'am. Yes, good evening to you all. Please suggest reference books. Hamad, I have already suggested some reference books in if you were attended our previous live session, like 3rd day or 2nd day, maybe yesterday or the day before yesterday, maybe. I have already referred so many books there. Just go the that live recorded live video, and you can just pause it where you need to do. So you can get so many reference books I have already mentioned, and with including all the topics, actually the physical chemistry, the important topics, and the inorganic chemistry, organic chemistry, including every topic I have more or less mentioned so many reference books, as you can refer those books. Okay, so let's start today's session with our first question. Okay, so this is our first question. Yeah, a molecule in solution crystallizes into two different crystal forms with rate constant of 0.02 second inverse and 0.13 second inverse. If the crystallization is assumed to be under kinetic control, then the half-life in seconds of the molecule will be. So you need to answer the correct option among those four. You have been given two different, actually the kinetic constant, actually rate constants, and you need to say what will be the half-life actually. Okay, so just try by yourself and type the comment. Hamad, yes, I have already told that all the reference books there. I have already mentioned in maybe previous or the day before yesterday, the second day maybe, all the important books. You can refer those things, okay? Yeah, Rajrupa answered the option 1, that is 4.6. That is here 4.62. So we got our first option from you. Anyone else would like to answer this question? Actually, this is very, very simple question, but an important concept actually asked from this question. If you get that point, get that particular concept, you will definitely can answer this. Okay. So basically, it is from your kinetics, chemical kinetics. Okay. If you, it is another important topic actually for you for the preparation of chemical science in CSIR net and GATE also. So many questions are coming from there, including the Michaelis-Menten equation and all the aspects of related to mainly kinetics. Okay. So any other option would like to say you? Anyone else? Hamad, are you there? You can answer the option, correct option. You are willing to, if. Okay, so let's try to solve how to approach this kind of problems. Okay, so this is basically I have already told that the chemical kinetics questions mainly. So just look upon our question. Here you have been asked that the yes, you have been asked the 1 minute. Maybe my pointer is not working. Yes, now it will be. Okay. So here you have asked that a molecule in solution crystallizes into two different crystal forms. That is, a process is occurring in two different paths and you are getting two different product. Okay. So with rate constants of 0.02 second inverse, that is K1, and another one is 0.13 second inverse, that is K2. Okay. So if the crystallization is assumed to be under kinetic control. Okay. So you need to know one thing, that is the crystallization of any molecular compound actually undergoes first order reaction. Okay. If you don't know this, just everything will be getting out from your head in the examination. And if you don't know this, then you can follow another trick. Just go to and see the unit part of the rate constant part. Here is this. That is 0.02 second inverse, right? And another one is 0.13 second inverse. So when you have been given the rate constant in the unit term, that is second inverse, so what is the unit for this? What is the mainly the parameter for this using? So we are using second inverse, means definitely it refers for the rate constant of first order. Yeah, you need to know this. You need to know all the units of first order, zero order, second order, and these things like this. Already actually up to second order you need to remember. Otherwise the nth order you can calculate, you know. Okay, so you need to remember this thing. So second inverse is given, that means you are already asked about the first order reaction. So you need to think in aspects of first order reaction, but you have been given two different kinetics rate constant. So that is the problem, that you are confessing, that you are feeling very much difficulty to solve this, which you are thinking that there may be two half-lives, right? Are you getting my point? You are thinking that that will give you two half-lives, but that is not happening here. So what is going to happen here? So let's try to solve. How to solve this? Yeah, basically this is nothing but an example of parallel reaction. Parallel reaction, actually parallel reaction is also an example of first order reaction. So crystallization of any molecule into two different products actually will take part in the parallel reaction. Okay, that is also first order reaction. So how this is possible? Yes, just look upon this rate equation. You know the rate equation, like it's K1 to K and K2 from the starting material M, and you will get C1 and C2. That is the product, C1 and C2. Suppose you have taken A1 or A2, nothing, anything else. So what would be the rate constant? That is dm by dt in minus sign. That is minus sign is indicated your what? That is the rate is increasing, and that with increasing time, and and with respect to decreasing your reactant molecules. Okay, so this is what you will get the rate. That is same concentration, the same starting material, K1 into M plus K2 into M. Now just take common from the M from both K1 and K2, and now you need to do, that is what you need to do, this integrate both sides. This you have already dt, just put it here and integrate both, and you will get this equation, right? Ln m0 by m. Why m0 by m? Because you have chosen the limiting value, the limiting conditions, that is m0 and bm, that is initial concentration was m0 and the final concentration, that is m. Okay, so that's why you have taken these things. So this is the rate law, the underlying things actually our rate law. Okay, so now you have been asked here that about the T half. Okay, so what is T half? How we can calculate this? T half means the when at the what amount of time actually the amount of starting material getting to reduced, or it will be reduced to half of that material. That is going to tell that our T half. Okay, half life. So just put the value m0 by 2, and you will get the ln 2 and calculate this. Just putting the value K1 and K2 here, you can calculate this and you will get 4.62, that is around 4.62. You can get the value. Okay, so the correct option is option 1. Yes, this is the correct option, option 1, 4.62. So am I clear to everyone? Am I clear to everyone? If yes, just make any comment or type anything in the yes or not, so that I can understand that whether I am able to making you understand or not. Okay, so this was our first solution about the kinetics, and this mainly about our parallel reaction. So you need to remember one thing, that's in kinetics, chemical kinetics, not only the Michaelis Menten equations. Apart from this, you need to consider, you need to read very importantly these parts actually, the parallel reaction, the consecutive reaction, the opposing reaction, everything related to that, related to those actually you need to prepare. Okay, so these all are including in your chemical kinetics. So this was from our chemical kinetic proportion, and large amount of marks actually, to weightage of marks actually that cover from our question paper actually, from kinetics. Okay, Papri, yes. So I am clear to everyone, right? Okay, so let's move to our next question. Yeah. So this is our next question, the question number 2. And the question is, the activity of water at 11 bar and 298 Kelvin is. So you need to find the activity actually of water at the pressure 11 bar and the temperature 298 Kelvin. So what is going to be the correct option among this all the options? Just try by yourself and type there in the chat box. At least try by yourself, okay? Try to solve this. This is it's a pretty simple question actually. Not actually simple. I am saying that it looks simple, but an important concept actually here we'll discuss. I will discuss this kind of important concept actually. CSIR every year prefer to give type of questions like important concepts, new concepts. Actually, they would prefer to include in the question paper. So if you just go through the previous 2 or 5 years, just you can see the pattern, how they follow, how they are thinking about which type of questions actually they're going to set there. So then you will have a great idea about that. Okay, anyone from you would like to answer this? It's a pretty simple question actually. Bhavani, good evening, ma'am. Bhavani, yes, good evening, Bhavani. I just skipped your comment actually. Okay, so let's try to solve this question, okay? How to solve this kinds of question. Okay, so you have been asked about the activity of water at 11 bar and 298 Kelvin temperature, okay? So basically, this is from your solution portion, obviously, and the important thing is that you need to consider here the special thing that is osmotic pressure. That is the equation, you all know this, that is pi equals to CRT, right? Osmotic pressure. Now, why you need to consider this? Why you need to consider this equation? Because you all know some basic things. In NTP or the standard temperature pressure, we can say, in NTP also we can say that is the concentration of water you all know. Okay, the concentration of water you all know, and that is such a 55.5 mole per liter. 55.5 mole per liter, and this is in your what condition? NTP. Okay, this is what. So if you know the concentration, and so also you consider the NTP value, like this is a standard temperature pressure. So you know the temperature and pressure also there. So it will be really helpful for you to get another value of water or concentration in another pressure or temperature, right? So just follow this concept which I am doing here. So you know the pi equals to CRT value. So now you know that pi is osmotic pressure, C is the concentration, R is also the constant you all know, and T is the temperature. So when we take the equation, like when we take when we taking the sometimes of our ratio kinds of things like pi 1 and pi 2. So pi 1 value for the temperature 1 and pressure 1, and pi 2 value for the temperature 2 and pressure 2. So thus we will equate those equation, okay, to solve. In order to solve this, that is pi 1 by C1 RT1 equals to pi 2 by C2 RT2. That it is pi 2 is at NTP and pi 1 is at 11 bar and the 298 Kelvin that is given in your question paper. The question that is you have been asked there. So let's put down the value. The pi equals to already 11. You know that there, right? Yeah, you have been given maybe 11 bar, actually bar. Okay, 11 bar. And 298 Kelvin, you know this. And C1, you don't know. You need to find this value, okay? And also in the pi 2 section, that is all the values you know, just put down there. Temperature, standard temperature to 73 degree Kelvin and 1 bar, you also know that. So just calculating this, you will get the C1 value, okay? This is the C1 value. So now you need to find the activity of water, AW. What is activity? Basically, it is the ratio of the two different concentration in two different temperature and pressure. Okay, so basically it's nothing but a ratio. Okay, so you can get the activity of water that is in C1 by C1 if you take the ratio. So C1 is 559.28 and the C2 is 55.5. So taking this ratio, you will get 10.07. Now you need to convert it into percentage. Why percentage? Because when you have already considered the NTP value, right? NTP, when you have already considered the NTP, that means the standard temperature pressure. So already you have been considered the 1000 ml in the consideration. The volume is in 1000 ml, okay? So now you need to take it in the 100 or in percentage terms, okay? So just do the percentage and you will get 1.007. This is our value actually, 1.007, and the option will be the option B. Yes, this one will be the correct option, 1.00 actually. Okay, so now I am clear to everyone. This is pretty simple question actually. You need to find the basically the activity. So Papri answered, that is option number B. Okay, yes Papri, you are absolutely right. That is option B will be the correct option. Okay. Okay, so let's move to our third question. Yeah. So our third question is the half-life, that is T-half for the hydrolysis. This is another question on your ester hydrolysis, that is on kinetics actually. Okay, so the half-life for the hydrolysis of an ester varies with the initial concentration of the reactant. E0 is given the initial concentration of the reactant as follows. How it will differ with the T-half or the half-life, the initial concentration, how differs, that is given in a table format. Okay, so E0 is given in the table format. So you need to consider the order of the reaction. So what will be the order of the reaction in the following options? Just type the option which you think that would be the correct option. Anyone would like to try this question? This is another important concept actually you have been asked here. Orghudeep answered option C. Okay, Orghudeep, you have answered already the question, the option C. Okay, so Orghudeep answered the option C, that is 2. The order will be 2. Anyone would like to answer this question? It's a pretty simple question actually. You can easily answer. Papri answered option B. Okay, Papri answered option B. So there are so many different type of question actually, options actually coming from you. Rajrupa also answered option C. Okay, fine. Muhammad, yeah, Muhammad answered 1 order, because when time increases, reactant decreases. Obviously, then when the time increases, the reactant will be decreased. It is the definite thing, Muhammad. You actually you have answered the proper thing, but what is the correct option? 1. You are going to say 1. Okay, so option B. You are going to say option B. Fever one Risa. Okay, option C. Fever one Risa, you have answered the option C, right? Okay, so we are getting so many options. Majorly giving option C, someone B, and mostly in B and C, right? Okay, so let's see which will be the correct option. So let's try to solve it. How to solve this kind of question? So just look upon our question. Here actually, you have been asked the T-half, okay? What is the T-half? So T-half of the hydrolysis of an ester. So just in our previous question, I have already told what is T-half. That is the time, the required time in which your initial concentration or your reactant concentration would become the half of the initial concentration. Okay, so it's pretty simple thing. So now you have been given a similar thing of T-half value and the initial concentration value, and you need to find the order of the reaction. So you need to know one most important thing when you are calculating the half-life in respect of your initial concentration. What is the relation between them? Yes, the relation is actually, this is the relation. That is T-half is directly proportional to your initial concentration, and the power will be 1 minus n. If the power will be 1 minus n, then it is directly proportional. In terms of this power, actually, we can say proportionally, actually. So if we just inverse this power, actually we will take that n minus 1, something like that. So just it will be inverse 1 by E0. Okay, the simple thing, the simple indices calculation, you all know that. So just depending upon this particular equation or the particular concept, you need to calculate it. Okay, so just take any 2 value from this table. You have given 3 value, but you know, don't need all the information. Actually, just take any 2 value, the E0 and corresponding T-half value, and take the ratio form actually. Okay, just ratio form and keep the n as order of the reaction, and just put the value 300 here. I am taking the 3 and 300 and 240. That is the second actually. And put the value E0, and you will get like 4 by 5 whole to the power 1. Just calculate these things. So now, how to solve these things, you know, that is in terms of indices. Actually, this is a basically indices calculation, basic algebra from your 11-12 concept. You all know that. So in terms of just to calculate this power, you need to come the base in the same manner, right? So you are taking this in 5 by 4 or 4 by 5 terms, and thus you will comparing the power term. You will get n equals to 2. The order will become 2. Another you can check, but you don't need to solve this in your examination. Already you have got your answer, but you can check if you have so many time, or if you have confusion, you can check with checking another any two value. Just you will get the same order or not. Just check this, okay? So you can get the order in the same thing, that is n equals to 2. So this is our order. Second order reaction basically. So this is the second order reaction, and the hydrolysis of ester. Ester hydrolysis is actually an example of second order reaction. So it's a pretty simple question, and the important concept that is you need to consider the T half and the initial concentration relation between the T half and the initial concentration. Okay. So am I clear to everyone? Yeah. So the people who told the option is C will be our correct option, right? So this is our correct option C. Option C, that is 2. So Muhammad, it is not the option 1, okay? It is not going to your option 1, not 0 order, also not B, not first order. It is actually the second order reaction, okay? So thus you need to calculate. You can calculate if you know this particular relation, you can easily calculate this, okay? Ester hydrolysis is pseudo first order, not second order. But you have been given some data in your example, in your actually problem, okay? So while you need to find this value in terms of the answer in their chat, actually the tablet form, okay? So just calculate those and just keep the formula in term this as it is, okay? You need to follow the basic concept, that is what is the basic relation. Actually, they need to ask this type of things. They need to ask that whether you know the particular concept, that is the relation between T half and initial concentration, okay? So if you know the concept, you can easily follow this, and whatever the answer you can get, you can. And if there is in the option there, you can easily mark those. That is the actually approach how you can solve or answer in your question, okay? Okay, so let's move to our third question, not third, actually fourth question, okay? Okay, so fourth question. The fourth question is asked, that is the density of NaCl. NaCl density at 25 degrees Celsius. You have also given the molecular weight. At 25 degrees Celsius is 2.16 into 10 cube kg meter to the power minus 3. Obviously, you have given the density value. The X-rays having wavelength 58.1 picometer are used. The 200 reflection occurs at an angle of 5.91 degree. So how many sodium and chloride ions are there in a unit cell? It's a very, very important question. Actually, this kinds of question regularly are coming in the CSIR net examination. And actually, this question is coming from your X-ray crystallographic diffraction. That is basically solid state, actually. Okay? So just try by yourself, and which will be the correct option you need to answer. Anyone would like to answer this question? Just try it, and which will be the correct option. Okay, Argodeep has asked a question. Ma'am, can we leave the general aptitude portion and can still qualify for JRF? Basically, Argodeep, it is possible if you have a very, very good conceptual knowledge or very good gripping in your subject. It is definitely you can do. Actually, if you look the pattern of your question paper, there are 3 sections, right? A, B, and C. So you should always start from your C section. There are a lot of options actually. You have like 65 questions. If I am not wrong, there are total 65 around questions in the section C, and you need to answer only 25 out of those. Okay, and each question carries the 4 marks, and if your answer will be wrong, then you will lose 1 marks. So just and you can have so many time before you starting the examination. You all have 3 hours, right? So I would like to suggest that the first 1.5 hour just keep for solving this section C part. Okay, so because there are so many mathematical questions, only subject basis question, and you need to solve this, you need to think about this, you need to do the mechanisms. Just if you are confident about your subject or particular topic, just start with those topics. Either it will be physical or inorganic or organic, anything your strong part. Let's start from those things. So suppose you have answered like 20 questions out of 25. You need to actually the maximum you can attend 25 questions. So actually if it is possible, you can answer 20 questions and all are right, then you will get 4 into 20, that is 80 marks, a large marks. Just you can solve only 20 answer and just you will get a large marks, okay, huge marks, okay. So if it is possible to 22 or 23, then you can in 3 into 4, that is 12 marks again you can get. So that's a lot of marks within at least 100 you can already clear. So when you already scored like 80 to 90 or around 94 in the section C, or suppose in 80 to 90 in the section C, so the large amount of marks you have already carried, okay. So you can think that already you have cleared the LS portion, because every the LS, in terms of LS lectureship, the cutoff actually around it's 94, 95 is near about that. If the question is pretty simple, around 94, 95, around this average this year. So you can very, very close to LS, or you can even crack the clears just using just solving the section C. Now you have you have lot of questions there. The section B, you need to answer there maybe 35 questions, right? Maybe I'm not wrong, there are 35 questions out of 40 questions, okay? So that is also some subject basis question. So then you can also answer another 30, not 30, as you can also 10 or 12 or 15, maybe 15. It will be pretty simple, and those are maybe if you have already corrected 10 questions, okay? So 10 into 20, and already you have collected the 100 or 110 marks that you can already reach to your Jrf cutoff. If the today's trend actually, last two actually CSIR net, we can see the Jrf cutoff is around 110 or 112 or 108, like this, right? So if you just scored this huge marks, like including your B and C section, that will be very, very helpful. And it can only possible if you have a very good gripping in your conceptual part or in your all the subject part. Then you can skip the section A part. Or otherwise the section I would like to say that you can answer the section B secondly, and you can take 1 hour for this to solving this, and the last remaining 30 minutes just keep for the section A. If you feel that any question is easy for you, it is just pretty simple and mensurations like type of formula, just a geometry formula, just an algebra, you can easily answer that, and you are confident about it, just then you can answer only 1 or 2 answers. It will help to just crack a good rank actually. So thus you can follow. It's pretty simple technique actually. Okay, so we are getting the answers of this question. Rajrupa and Fiva Vanrisa. Sorry, Fiva, I can't actually. I have a difficulty problem for you to answer you, actually to pronounce your name. So sorry for this. And your option is option 2, right? Okay, so let's see how to solve this kind of question. Okay. So let's look upon our question. This is basically from a crystallographic question or the solid state. Okay. So basically you have been given the density here. Yes, you have been given the density value here of NaCl. Okay. And also, so the plane is given here 200 plane, the reflection plane. You have given the theta value, that is the angle of diffraction. Okay. You have been also given this. So you need to find the number of sodium and chloride atoms are present in the unit cell. So how to find this? Basically, you need to know if you've read the properly the solid state, you have already know the basic concept from X-ray diffraction, that is the Bragg's law, right? That is n lambda equals to 2d sine theta. This is our basic equation, n lambda equals to 2d sine theta. Okay. You know all this, and when you have been not actually told about the order of the reaction, that is N, you can take it as it order 1. Okay, you can consider this. You are allowed. So now you know N equals to 1, and you know the lambda equals to 2d sine theta. Now you have been given the D value, not D value, the plane you know, the 2, 0, 0. The theta value you know, lambda value also you know. So you need to find the D value, that is the spacing between two plane, you need to find. So basically just equate it and you can get the D value by using the lambda and 2 sine theta value. Okay. So another thing is, you also know how to calculate D. Another formula is A by root over H square plus L square plus K square. What is this? Actually, I'm going to say A by root over H square plus K square plus L square. Okay. This is what? H, K, L are the coordination, actually the coordination term of the particular point, and A is what? The unit cell length actually. Okay. So basically by putting the value, you have now the coordination, actually the plane, the 2, 0, 0, right? So just put the value 2 square, need to consider the square also. 2 square, K square, that is 0 square and 0 square. You will get the 4 square, that is 2 square 4 actually, and you will get by root over this term, and you will get that's 2. Okay, A by 2. This is the value actually you get, the underlying thing. Okay. Okay, so now the thing is, you need to consider the molar volume. Okay, where is this? Yeah, the molar volume. Okay. Molar volume means the molecular weight, that is the molecular mass actually, divided by its the density. Why you need to consider the molar volume? Because you have been given the molecular mass, the molecular weight. Okay, so you need to consider this thing here. So you will get what type of volume? The molar volume. Okay, so thus calculate, put the value and you will get the volume. Okay. Yeah. Another thing is, you also know what is the volume of the particular cell. How will be the volume? It will be calculated? You also know that is the unit cell length A, just taking its cube, because it's a cube-like structure. So just taking the A cube value, you can also calculate the total volume. Okay. So now you know these things. The molar volume means it consists mainly the Avogadro number of molecules. How many ions here there? Molecules means here the ions, the Na plus and the Cl minus. So how many ions are there in the molar volume? Here you will get the 6.023 into 10 to the power 23 ions. Okay, that's the Avogadro number. Okay, so if you get this Avogadro number here and you know the volume for molar volume, you use the unitary method, and just pretty simple thing. You use the unitary method, and what will be the total volume? How much you get the NaCl and Cl minus? Just calculate it, and it will be around 3.9, and just approximation this, you will get 4. So basically you will have in the particular unit cell 4 Na plus ion and 4 Cl minus ion. So basically the answer will be option 2. Okay, so this is our option. So am I clear to everyone? This is a very important type of question, and the concept basically asked here. You need to follow this. Yeah, Rajrupa and Fever, yeah, both of you given the correct option, option 2. Okay, so I am clear to everyone, right? So let's move to our next question. Yeah, question number 5. So this is the question: an electron accelerated through a potential difference of phi impinges on a nickel surface whose the plane is 100 planes have a spacing difference, that is D, is given into 10 to the power minus 12 meter, that is in picometer. And the Debroglie wavelength of electron is lambda in picometer is A by phi root over A by phi. The value of A in volt. You need to find the value of A in the volt actually. Okay. So what will be your correct option? Just type the option here so that it will be visible to me. Just try by yourself. Orgodeep saying, ma'am, NaCl is FCC structure, so without calculation can we write it? I will suggest, no, Orgodeep, you should not do this during your examination because it is a numerical part, right? So you have been given the particular data. You can check this whether it is wrong or right, or it will be right. But you don't need to do that, because sometimes what happened, anything data will be you have been provided in the question paper may be wrong, but you need to calculate in terms of that data. Okay, so maybe they are calculating some with a different with a wrong data, but they are getting the options, they are getting the answer. Actually they have already put it into the into the options. So you need to, if you consider all the data they have provided, you will definitely get that answer practically given in the option. So it is will be safe side for you that you also attend though the question is wrong, they have given the wrong data, you will definitely get the marks for this if you attend the question. But it is another thing, that is you are in the safe side, right? So you need to cautious to prepare or to answer in terms of your CSIR net, right? So you should not take any risk. Okay, so just follow these things. Okay, so I will suggest, just don't write anything mugging up any formula, anything, just write in the option. But you need to calculate, just go through the given data there and then calculate and then answer. Okay, so what is this? That is the answer for this question number 5. Are you getting my point for the previous question? So if that was solved, you can now solve the question number 5 and you can write the correct option. Basically, this is another thing. Actually here the solid state concept, the X-ray diffraction concept is also applied here, and apart from this, actually the potential difference is also, the Debroglie wavelength also applied here. So consider these things and just try to solve. Orgodeep, thank you, ma'am. Okay, welcome Orgodeep. Just stay tuned. Okay, so let's try to solve this question. How to solve this question? So basically you have been asked here, the electron accelerated through a potential difference. You have been given the potential difference in 5 volt, okay? And you have been also told that, told here the information that is 100 plane. The plane also, the coordination also have been given. D, the spacing difference also given, though you don't need this here, but it's a safe side, that is you have been given the, actually the value here. Okay, so now, the Debroglie wavelength of electron lambda equals to a by root phi, actually by root over a by phi. So how will be the value? What will be the value of a? You need to solve, you need to find actually. So how to solve this? Okay, so you all know the Debroglie wavelength, right? Lambda equals to h by mv. Debroglie relation, you all know that. Lambda equals to h by mv. mv is the mass and velocity of the particular electron. So in terms of kinetic energy, or in terms of energy, how you can rewrite this formula of wavelength, the wavelength relation? How? You know that the kinetic energy actually follows half mv square, okay? So basically v is the velocity, and what will be the velocity? That is root over 2e by m. Just put that value in the velocity in the equation and you will get h by root over 2 pi m, okay, 2me, okay? So now you have been given in the question, that is the E value, energy is in electron volt, that is E into V, okay? That is, you need to consider the electron and also its volt in the potential, okay? So this is basically, you need to calculate h by root over 2m eV. E is the electron and V is the velocity. So now you have been given a particular relation here. You have been already told there. That is lambda equals to root over a by phi. That is the de Broglie relation. So just equate these things, both the equation, equate and put the value of h, Planck's constant. You already know that 6.634 and 10 to the power, or 6.6 you can use for the approximation, into 10 to the power minus 34 joules second. And all the other things, that is 2, and m is the mass of the electron, 9.1 into 10 to the power minus 31. And E is the charge of the electron, 1.6 into 10 to the power minus 19 coulomb. And phi, also the volt. You know that is the coulomb, and phi, the potential is also used there. So what is going to happen here? if you take the square term for both sides, you will get a by 5 equals to h square by these things. Root over sign will be cancelled out, okay? So now cancel out the 5 from both sides. Cancel out the 5 from both sides, okay? So now you will have a. Calculate this and you will have the a value. Basically, you will get this value, 1.5 in 10 to the power minus 18 volt. So the correct option will be option A, right? You got this answer, 1.5 in 10 to the power minus 18. Okay, so are you getting my point? Am I clear to everyone? Rajrupa is answered option A. Yes, Rajrupa, option A is the correct option and you are absolutely right. Okay, so if I am clear to everyone, just move to our next question. This is a pretty simple question actually. The solution is also showing here. Just follow the Debroglie relationship, anything else. Just follow the Debroglie relationship and put the value there and you will definitely get your that value which you have been asked. Okay, so CSIR net coaching for chemical sciences, the new batches will be start from the 4th March of 2022. And we will provide actually the exam focused daily classes, the printed hard copy study materials, unlimited expert assistance and doubt solving via chat, class tests, monthly practice exams, all India level test series, video backups of all classes and much more things. Okay. So if you are really interested in our classes or daily lectures, just you can register your name and just you can also for your reference, you can call the toll-free number given below. Also can go to our official website and you can buy anything or study materials or books, anything related to that in our store. Okay, so this is the thing. So let's move to our next question. This is basically from your inorganic part. The question is, the red color of oxyhemoglobin is mainly due to what? You need to answer the red color of oxyhemoglobin for what reason? Basically, the options are DD transition, metal to ligand charge transfer transition, ligand to metal charge transfer transition, and the option D is intra-ligand pi star transition. So which will be the correct option? Okay. Argodeep answered option D. Okay, Argodeep answered option D. Mahesh Prajapati, you have any answer? Okay, he has also again answered. Okay, Mahesh, given the option C is the correct option, he told. Okay, Fever is optioned option A. Okay, so we are getting so many options. A, C, D. Almost all we have got here. Okay, so let's try to solve how to answer this type of question. So basically this is your bioinorganic question. It is coming from your bioinorganic part and you need to remember the bioinorganic is very, very important topic in your inorganic concepts. Okay, so besides the organometallic, the coordination chemistry, bioinorganic also actually take a large amount of marks in the question. Okay, so you need to definitely clear all the things, hemoglobin, hemocyanin, oxohemoglobin, everything related to this. You need to just go through that every concepts. Okay, so you have been asked here the oxyhemoglobin mainly why it is red color. Okay, so you need to answer this question. So you need to know this concepts actually behind this, that is the iron. The hemoglobin, there is the iron center, basically Fe2 plus. When it is binded to the oxygen, that is it will turn into the oxohemoglobin. Okay, so what is going to happen? Basically the Fe2 plus and going to happen it with the D, that is the D electron in this case, actually it becomes a low spin case. It achieves a low spin when it is whenever it is attached to oxygen atom in the oxyhemoglobin form, the Fe2 plus will eventually turns into the low spin case or the low spin moving electrons. So basically Fe2 plus, you know the configuration, that is D6 electron. Okay, so now it will follow the low spin case. Okay, the low spin case means you know that the d orbital is split like this, T2g and Eg, and there will be a large energy difference between Eg and T2g. That's why the pairing energy will be more higher than this, actually this transition energy. Actually, that's why this is the main reason. This is the high energy difference between the Eg and T2G. The T2G electron cannot go into the Eg, or it will be very, very difficult actually, not go, actually it will be very, very difficult. High energy, they will need to cover actually. So this high energy difference actually will give your red color. This is the main reason for your red color. Okay, this sharp transition actually. So this is the main reason. So this is nothing but the case of DD transition, because you know that the D electrons here, from T2G to Eg is transition occurs here. No charge to CT, no charge transfer cases here, no the ligand to metal and anything else. This type of case is not observed here. Only the DD transition. The DD transition is the main reason for this. So basically the option A will be the correct option. Okay. So this option will be the correct option. Option A. So are you getting my point? Am I clear to everyone? Option A, yes, Bhavani, option A is the correct option. Fiva, option A, yes, you are absolutely right. Rajrupa, and you are also absolutely right. The option A will be the correct option. Okay. So if I am clear to everyone, let's move to our next question. Yeah, basically this question is from your organic question. Yeah, the compound that is not aromatic here. You have given 4 different structure, and you have that is shown in the screen, and you need to say which one is not aromatic. Not aromatic. That is not aromatic structure. What will the correct option? Please try by yourself and just give the proper answer in the chat box. Okay. Mahesh Prajapati answered the option D will be not aromatic. Okay, Mahesh, I took your option. Anyone else would like to try this question? What would be the not, but that's not the aromatic compound actually. Bhavani said that the option B. Okay, option B. Bhavani is saying the B molecule. Okay. So we are getting 2 options. But Bhavani, okay, option B. Acha, okay. Muhammad also answered the question. This question is option B. So many answers are coming from you, and most of the cases those are answering the option B maximum. So what will be the correct option? Actually, basically this is the aromaticity question. If you know the basic rule of aromaticity, that is the Huckel's rule, that is any aromatic equation molecule will go follow the particular formula, that is 4n plus 2 pi electron rules. If they follow this particular formula, they become they're going to be aromatic. So not only the formula, you should think this particular 3 important point actually. If the molecule follows the Huckel formula, that is 4n plus 2. Number 2 is if the molecule is all the pi electrons are conjugated. That means they all they participate in the conjugation. Okay. And number 3, all the carbon atoms must be actually sp2 planar and sp2 hybridized. Okay. These 3 important points if followed, then definitely that molecule would go, it will be show the aromaticity. Okay. So for anti-aromaticity, you all know that basically the formula is 4n pi electrons. So basically the Huckel rule is that they should follow the 4n pi, and all the other options remain the same. So here for each and every molecule, if we calculate the 4n plus 2 rule, right? For each and every molecule, let's start with our molecule 1 actually. Okay, this one. So here you will see that the 6 pi electrons here there, and this also follow the 4n plus 2 pi electron system, and all the carbon atoms are sp2 and planar. Okay. So let's move to option C. There are also 6 electron pi electrons is 4n plus 2. Follow the Huckel's rule. And option D, if we see this, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, 10 electrons. This is 10 annular ring actually. 10 annular ring. And this again the example of aromatic actually. So 4n plus 2 pi electron rule this follow. So only the option B, here the 8 pi electrons is present, and they doesn't follow the 4n plus 2 pi electron. They don't follow, but they follow the anti-aromaticity, that is 4n pi electron system. The n equals to 1 here. So basically option B will be the correct option, right? Option B will be the correct option, yes. So this molecule would show the non-aromaticity actually. So are you getting my point? Muhammad answered cyclic conjugated planar sp2, then 4n plus 2 aromaticity, 4n anti-aromaticity. Yes, Muhammad, you are absolutely right. This is the actual factor working behind this. Okay, so let's move to our next question. Okay, so this is another question and asking from the in the form of pericyclic reaction, actually, in terms of pericyclic reaction. So the reaction is shown in the screen. The reaction between X and Y is given, and you need to answer. Just read the options. Either it is 4-pi contrary opening of X followed by endo-Diels-Alder cycloaddition or any other, or disrotatory, or just go through the options and you need to answer the question. It's a very, very important concept actually asked here, and the pericyclic reaction is very, very important in your organic portion. Okay. So anyone would like to answer this question? It's pretty simple actually, but conceptual. Anyone would like to answer? Okay. Okay, so okay, Bhavani answered option D. Okay, Bhavani answered option D is the correct option. Okay, so let's try to solve. How to solve this kind of question? Basically, if you know, that is, you have been given here, that is the heat temp sign. Okay, so thermal mode. So the basically the process is going to thermal mode. Okay, so thermal mode, when the reaction is passing like this. So in thermal mode, what number of electrons actually are taking part in your bonding formation or bonding or bond breaking terms? So you need to find those. Here, just follow this question, this molecule actually. In this molecule, what is going to happen here? Yes, here. Just see this 2 pi electrons. This 2 pi electrons and this bonded electrons actually. That is 2 plus 2, 4 pi electrons actually taking part into the reaction. Okay, so you also know this. You need to know, actually must know, that is when there is even number of pi electrons are taking part in the reaction, and that is a thermal mode. Then eventually that takes part in the con-rotatory opening. Okay, and when the odd number of electrons are taking place in the thermal mode type of reaction, then that will taking place through the disrotatory opening. Okay, so in terms of photochemical mode, just the reverse order is happening there, just the reverse case. Okay, so basically in first step we will get a con-rotatory opening and the 4 pi electrons will take place and we will get this product. Now you have been given another molecule. Just look upon the molecules. So you will see that it will go the Diels-Alder reaction. Okay, so you know, pretty simple. This is Diels-Alder cycloaddition reaction. And you will get the product that will be the XO as a major product. You all know that how we will get this. So this is basically a Diels-Alder reaction actually after that. So you will get this product. So option C is the correct option. Okay. So 4 pi con-rotatory opening of X molecule X followed by the XO Diels-Alder cycloaddition. It's a pretty simple conceptual thing is asked here. Okay. So are you getting my point? Option C will be the correct option. Okay. Okay. So let's move to our ninth question. Okay. So another pretty simple question. Okay. Before going that, I would like to show you the mechanism if you would like to see it again. Okay, this was the mechanism actually. Okay, so ninth question is, you have been asked the order of the basicity of the following molecules. So there are first molecule is what? First molecule is the piperidine. Second is not piperidine. Sorry, first molecule is pyrrole. Yes. First molecule is pyrrole. Second molecule is indole. Third molecule is your pyridine, and fourth molecule is piperidine. Okay, so what will be the order of the basicity? It's a pretty simple question. You can readily answer this question. What will be the answer? Just type basicity question, right? Okay, Muhammad answered. The option A will be the correct option. Okay, we are getting the answers from you. Okay, so let's try to find how to solve this kind of question. Basically, you know that the basicity is measured by the availability of lone pair of electrons over the nitrogen atom. Okay, so how it will be, as the amount of the nitrogen lone pair is over the nitrogen will be rich or high, amount this high actually. So it will show eventually the higher basicity order. okay? Otherwise, it will show the lower basicity order. So just look up on the molecule in the piperidine, actually the fourth molecule, okay? The fourth molecule, that is a piperidine molecule, this molecule. So all the nitrogens here attached with the cyclohexane ring and all the lone pair actually basically over the nitrogen and are readily available to show the basicity. So it will show the highest basicity order. Then the 3, that is the pyridine show. Why pyridine? Because this is also another case of another actually nitrogen also attached to 6 carbon atoms. This is benzene ring. But the thing is, all the pi electrons are conjugated, but the nitrogen over the lone pair over nitrogen here doesn't take part into the conjugation. Doesn't take part in the conjugation. Since what is going to happen here? The lone pair actually remain in the pure S orbital, okay? So, and actually the thing is actually the p orbital, okay? So what is the thing going to happen here? That will the lone pair is not periplanar or to the benzene ring, actually perpendicular with the benzene ring. So it cannot take part in the conjugation, okay? So, and another thing is also the nitrogen is double bonded, so more electronegative. So already the availability of nitrogen, the lone pair over the nitrogen, it going to be somewhat less. So this is next basicity order. Then we will get the third order is for pyrrole. That is of molecule number 1. Okay, this one. This one. So here the lone pair actually takes part in the conjugation with the ring, and in the pyrrole and in the indole, actually this molecule, the lone pair obviously undergoes the conjugation with both the ring, and the extended conjugation will be in large in manner, okay? The extension is very, very large. So particularly the order will be actually, yes, the C, the 4 will be maximum, then the 3, then 1, then 2. So are you getting my point? Am I clear to everyone? Okay, Rajrupa asked, that says option C is the correct option. Yes, option C. Mohammed also said sp3 is more basic than sp2. One molecule is basic because of aromaticity. Actually, you have told the proper concept, that is sp3 is more basic than sp2. That is fine, but not one molecule, because because it is actually one molecule of pyridine. You have told what? One molecule, okay. Not one molecule, because it's also pyrrole is also aromatic compound, and another thing is indole is also aromatic, showing the aromaticity, but the extent of conjugation is more there in a case of 2, because we have both the ring, the 6-membered and the 5-membered also. So a conjugation, we know that the more the conjugation, the more the electron will be delocalized there. So the availability of lone pair to show the basicity is less actually, okay. So this is the concept. And the last question is, yes, under the equilibrium, basically equilibrium part is another important portion for your topic for your preparation of chemistry. Under the equilibrium condition for the reaction is given like that. The total pressure is also told, the 5 atm, the value of Kp. You need to find the Kp value. So, Bhavani, yes ma'am. Yes, Bhavani, if you got my point, then yes, it's fine. And just try to solve this question. What will be the correct option? Okay, so let's try to solve this. It's basically equilibrium question, okay? So here what is happened, if you know the equilibrium pattern, that basically how to represent the equilibrium constant in terms of concentration. If you know this, you can write this basically this equation actually, and you know this is basically the solid portion carbon. Actually, the solid, actually we don't consider it, because in solid state we all know the activity is 1, is like that, okay? So you can say that P, it is the partial pressure, and for CO, that partial pressure will be 2P. Why 2P? Because you have the stoichiometry, okay? So consider this. So just, you have given the total pressure, so you can just add the both value, and you can calculate the pressure. So the partial pressure for each, not for each, actually P value you now know, that is the 4. So basically you can say then the partial pressure for CO2 is 4. Why CO2 is 4? Because here you consider the P value, okay? And for CO it is 2P. So that is the 2P, the 4 into 2, you will get the 8. So now you can write the Kp in terms of this. Kp is basically Kp, how we can write this. Kp equals to partial pressure of the product, that is CO here, and you have to consider the actually power, that's the stoichiometry. So it will be get the 2 over here and divided by partial pressure of CO2. Okay, the power is also 1 here. Now put the value here and you will get that is 8 by 4, 8 by 4, okay, and you will get not 8 by 4, actually 8 square by 4. Yeah, a square term is also there. So you will get 16. Okay, so this is the correct option. Actually, option is the correct option. Yeah, 16 is the correct option. This is going to be our option. So is it clear to everyone? Bhavani, yes ma'am. Okay, if it is clear to everyone, this is a pretty simple question from your equilibrium actually. Then this was the today's question, 10 question, which are very, very relevant or important for your CSIR net. So one thing I would like to say is if you have a very good preparation, just go through those all topics, just keep preparing yourself and be positive on your, or confident on your preparation and keep practicing, okay? So that is what I can say for today. So all the best everyone and thank you very much.